Hello there and welcome to the series of videos going through the content of A-Level Maths. Here we're looking at the product rule for differentiation, a really useful rule to help us differentiate a function where we've got two separate functions that we know how to differentiate separately, so we can answer questions from exercise 9D. So, in this video then, we're going to be looking at how we will differentiate functions that look like this, where we've got a function times another function where we know how to differentiate the functions separately. Unfortunately, it's not as easy as just differentiating the one function, differentiating the second function, and multiplying the two together. There is a slightly more complicated rule that we need to follow. There's a reason for this rule existing. Some people like it in this notation where we've got one function times by another function. Some people like to use u's and v's. I'm a person that likes to use f of x and g of x as my functions for f of x and g of x. Make sure you don't get this rule confused with the chain rule that you've seen in the previous video where you've got one function of another function. This is a composite function. This here is a multiplication of two functions. So what we're going to do is we're going to prove this rule from first principles, but you do not need to know how this rule is proved. So what we're going to do is we're going to be differentiating f of x, g of x, the two functions being multiplied together. So start with f of x times g of x in your differentiation from first principles. Do a little bit of maths, rearrange, introduce something here where you've got a negative and a positive of it. Split into two separate fractions. I'm going to whiz through this really quickly because it's not something that you need to know. But what we do end up with though is this rule here where we have the differential is equal to, if you can see it in really small writing down the bottom, f of x times the differential of g add g of x times the differential of f. So effectively what we've got to do is differentiate one of them but keep the other function the same, and in the second part of it do it vice versa. Differentiate the other function and keep the previous function the same, and then add the two results together. So here is the rule then. If you've got one function f of x, g of x, two functions that are being multiplied together, and you know how to differentiate those two functions separately, then keep one of the functions the same but differentiate the other one, and then add this on to keep that function you've just differentiated the same now before it was differentiated, and differentiate the other function you kept the same in the previous differentiation. Okay, you can use either of these notations. You do not get these formulas in the exam, so if you prefer this notation here, you're keeping u the same but differentiating v. And then in the second part, you're keeping v the same, but differentiating u. Okay, so what we're going to look at now is applying this in a real question. So we've got f of x equals x times sine x. Now we've clearly got two functions that are being multiplied together here. We've got one x function and one sine x function. These are two different functions that are being multiplied together. So in this case, it's really obvious to identify product rule is the way to go with this one. So the left hand side is x, that's your f of x function. Doesn't really matter what you label them as. F of x we're going to call as x. Not to be confused with this f of x, I'm using f of x in the product rule that's up here rather than f of x what the question's been called. The second function that we need is g. G is the second function that we have in this question here, that's sine x. Differential of x is 1, differential of sine is cos. And now that we've done this basic work here, we can now just apply the product rule. So substituting in the functions into the product rule where they're needed, and we're going to do it like this. So f dash of x first times g of x, so it's going to be 1 times sine of x first, so effectively multiplying these two bits together. And then it's going to be f of x times cos of x, the differential of g, so effectively timesing these two ones together and adding the results together. So it's going to be 1 times sine x, add x times cos x, and leaving your final answer just by expanding the brackets and neatening things up. Sine x plus x cos x. So there we are, that's the answer to differentiate this function here, where you've got two functions that are multiplying together. Let's have a go at another example here. We've got, this time our function is x to the 4, e to the 3x. Clearly got two functions here that are being multiplied together. So write the two functions out and differentiate them, because we're going to need these results in our product rule. So x to the 4 differentiates to 4x cubed, and e to the 3x differentiates to 3e to the 3x. Now, all that's left for us to do now is, now that we've done this basic work here, is to just substitute the results into the formula. So f dash of x is going to go in first, then it's going to be e to the 3x, so effectively multiplying these two together. And then it's going to be x to the 4 times 3e to the 3x, so effectively timesing these two together. So substitute them into your formula. F dash of x is 4x cubed, g of x is e to the 3x. That would be add f of x, which is x to the 4, and g dash of x, which is 3e to the 3x. Tidy things up by removing the brackets and simplifying where possible. 4x cubed, e to the 3x, plus 3x to the 4, e to the 3x. Okay, next one. This time the function is a little bit more complicated. Ln x cos x. So here we've clearly got two functions that are being multiplied together. So our first function is ln x, that differentiates to 1 over x. And the second function is cos x, that differentiates to minus sin x. So all that's left for us to do is now just substitute these answers into the formula. And it's going to be 1 over x times cos x plus the original f function ln x times minus sin x, and just tidy up your answer, so it would be cos x over x minus ln x sin x. Okay, so what's quite nice, I would rather do this in an exam and know that show that I know how to differentiate functions separately and then apply them into the formula, and it's quite a nice, neat way of showing your workings out. Final one then, x squared times the square root of 3x minus 1, and we're asked to differentiate this, so clearly two functions that are being multiplied together here. So our first function is x squared. Differentiate x squared, you get 2x. The second function, a little bit more fiddly to work with. We've got the square root of 3x minus 1. So we're going to need to change this into something that looks differentiable. 3x minus 1 all to the power of a half. And in this case, we're now going to have to apply the product rule. So differentiate the inside function first, that's 3. Differentiate the outside function second. So it's going to be 3 times, and then differentiating x to the half effectively, or the power of a half. Half moves to the front, 3x minus 1. Reduce the power by 1, so it's minus a half. You might want to simplify this together before we move on to the next step of the product rule. So now we're going to apply the product rule. It's going to be f dash of x g of x plus f of x g dash of x, and just substituting in the appropriate expressions where we've got them. So differential of f is 2x times g of x, which is 3x minus 1 to the power of a half, plus x squared, the original f function, times the derivative of the g function, and just tidy up where possible. 2x times the square root of 3x minus 1 plus 3x squared over 2 square root 3x minus 1. Okay, so there we are. Pretty tricky question, that one. Oh, we've got another one. Perfect. Given that y equals e to the 4x sine squared 3x, show that dy by dx is equal to this big long thing here where a and b are constants to be found. So we can clearly see here by this function here, we've got the product rule. We've got one function clearly being multiplied by another function. So the first function is e to the 4x, and differentiate this to get 4e to the 4x. G of x, the second function, is sine squared 3x. I'm going to have to use the chain rule here. So differentiating the inside function first, that's going to give us cos 3 cos 3x. So inside function first, 3 cos 3x, and then differentiating the outside function second. The outside function is the square, so that's just going to be 2x, so, or in other words, 2 times sine 3x to the power of 1. Bung this back together and you're going to get 6 sine 3x cos 3x. So hopefully you're good at chain rule. Hopefully you've had a lot of practice in exercise 9c, because you're going to need it in the product rule and the chain rule, the product rule and the quotient rule later on. But what we're going to do now is we're now going to apply the product rule. So this is the product rule, and let's now substitute in the values where appropriate. So differential of the first one, 4e to the 4x times the original g function, which was sine squared 3x, plus the original f function, which is e to the 4x, and then times that by the differentiated g function, 6 sine 3x cos 3x. What you may have noticed is that my version of the product rule here is different from the product rule version up here, but if you can imagine, rearranging the order in which things are multiplied doesn't affect anything, and the order in which we've added things together doesn't matter either. So these two rules here, they look different, but they're exactly the same rule really. Coming back to this product rule here, we now need to expand the brackets and simplify. So in this case here, we've got a sine function that's in common between both of these expressions here. We've also got an e to the 4x that's in common between these two expressions here. So for the first one, we're going to have 6 cos 3x. For the second one, we're going to have 4 sine 3x. So this is our answer here. So your answer here is a equals 6 and b equals 4. Okay, so that is the product rule then. So your turn to have a go at these 4 questions here. We've got another page with a few more challenging questions later on. So pause the video and try these 4 questions out. Okay then, so for the first function here, we've clearly got 2 functions that are being multiplied together here. The first function is sine 2x, and the second function here is e to the 3x. Now what we're going to need is the derivative of both of these, so we might as well work them out now. Differential of sine 2x is cos 2x, 2 cos 2x. Differential of the g function is going to be 3e to the 3x. And now we're just going to apply the product rule. So dy by dx is equal to, I'm going to effectively kind of cross multiply here. So it would be 3 sine 2x e to the 3x. I'm trying to simplify as I go along here. And then it's going to be 2 cos 2x e to the 3x. So there we are, that's the answer for the first one there. Second one, we've clearly got 2 functions that are being multiplied together here, e to the 4x and ln x to the 4. What I'm probably going to do is I'm probably going to change this function here into 4 ln x using one of the laws of logs. A power can always be pulled out as a scalar factor multiple at the front. So what we're going to need next is the derivative of both of these functions, so 4e to the 4x and 4 times 1 over x, or in other words 4 over x. If you didn't do it this way, you should still get the same simplified answer there. And now let's just apply the product rule. So effectively we're kind of cross multiplying here, so it's going to be e to the 4x times by 4 over x plus 16 e to the 4x ln x. And simplifying this, we are going to get 4 e to the 4x over x plus 16 e to the 4x ln x. So there we are, that's the answer to the second one there. The third one, let's keep this as it is, I think, for this one here. F of x equals ln 5x squared. And g of x is equal to sine 3x. Clearly here we've got two functions that are being multiplied together. What we're going to need to do is differentiate both of them at some point, so we might as well do it now. In this case, it's going to be 10x over 5x squared, which is going to simplify to 2 over x. And for the g function differentiated, it's going to be 3 sine 3x. So let's now apply the product rule. So we're kind of cross multiplying here. So the first one's going to be dy by dx equals 3 sine 3x ln 5x squared plus 2 sine 3x all over x, simplifying as we go along if you can. Okay, so there we are, that's the answer to the third one. And the answer to the fourth one, the first function is going to be x to the half. And the derivative of this is going to be half x to the minus half. And the second function here is going to be, we've clearly got two functions that are being multiplied together here, so we're going to use the product rule. G dash of x is equal to 1 over x. Now applying the product rule, kind of cross multiplying here, so it's going to be x to the half times 1 over x. I can simplify that as I go along. That x to the half divided by x is going to be x to the minus half, and then plus half x to the minus half ln x. So there we are, that's the answer to the fourth one then. So hopefully those went okay. Difficult, getting used to it to start off with, but okay. Have a go at these two at the back here now. Now these are quite difficult. These are going to use your knowledge of product rule and chain rule combined into one question, or two questions rather. So pause the video and try these two questions out. Right, okay, so for the first one we've clearly got two functions that are being multiplied together. The first function is 3x plus 5 to the power of 7. And let's differentiate this while we're here. So we're going to differentiate this by the chain rule. First we're going to differentiate the inside function, so that gets to a 3. And then we're going to differentiate the outside function, so effectively times the power to the front and take away 1 from the power. So this here is going to be 21 3x plus 5 to the power of 6. The second function here is just your bog standard sine x, and sine differentiates to cos. And the final thing we're going to have to do here is just put this all back together. So applying the product rule now, so do a bit of cross multiplying. 3x plus 5 to the power of 7 times cos x plus 21 3x plus 5 to the power of 6 times by sine x. Good, perfect. Second question, a bit more tricky here now. So the first function is going to be, let's put it into something that is differentiable, 5x plus 2 to the power of a half. Let's differentiate this while we're here. So differentiating the inside function first, that's 5. Then differentiating the outside function second, that's going to be a half, 5x plus 2 to the power of minus a half. So we've effectively treated this as an x to the power of a half, so times the power to the front and reduce the power by 1. The next thing we're going to do is look at the second function. We've clearly got two functions that are being multiplied together here, so that's e to the x, and the differential of e to the x quite nicely is just e to the x. So, therefore, applying the product rule, and I'm going to try and simplify as I go along here as best as I can, doing a bit of cross multiplying, the answer is going to be 5x plus 2 all square rooted times e to the x plus 5e to the x over 2 I'll do square root 5x plus 2 square rooted on the bottom. Good, okay, so the reason that it's like this is that we've got 5 over 2 from this 5 over 2 here, and it's x to the power of minus a half. Minus will make the bracket here move to the bottom, and the half will make it a square root. So 5x plus 2 is inside a square root on the bottom because it's a minus half power. Right, quite some tricky differentiation here. It is starting to get quite difficult. That means we need lots of practice. Practice, and you'll get better and better and better and better and better. So, pause the video and have a go at all of the questions from exercise 9D. There's no use in skipping any of them. We want you to be really good straight away and really good at the hard exam type problem solving questions towards the end of this exercise as well. Okay, thanks very much for watching this video.